In this video, I'm going to be showing and animating the fundamental trigonometric functions of sine and cosine. I'll show you how they work and what exactly they do. We will start with a white line from which theta is measured and a red line to the line which we're rotating relative to the white line. I will draw a circle like this in a minute to show how we can rotate this red line relative to the white line on coordinate axes. Let's overlay coordinate axes with horizontal labeled x and vertical labeled y and draw a circle with the tail end of the red line. The radius here I've chosen is r equals 2. Now we will write out the equations of sine and cosine. Let's then multiply both sides of both equations by r to get coordinate values of x and y by themselves. We'll be taking the values of r and theta and plugging these values into the functions to get a measurement that I will show momentarily. First, we'll examine the cosine function and its graph x versus theta. You can see that as theta increases, the graph on the left just oscillates between 2 and -2. I want you to think of a light pointing towards the horizontal axis such that the red line is always between the light and the horizontal axis at all times. This light casts a shadow that is created by the red line onto the x-axis. The shadow is the green line that you see here. Let's now introduce a coordinate pair that falls on the circle in the xy plane. Now, performing rotations, you can see how the value of x changes for different angles of theta. I will now allow some rotations to play out while you think about this, but I want you to keep in mind that this coordinate pair is first written with the x value followed by a comma and then the y value, if you did not already know. I want to now investigate some crucial points on this graph. The first ordered pair I want to investigate is cosine of 0 degrees, which on a circle of radius 2 is the ordered pair 2, 0. As you can see, the shadow is fully along the x-axis and cannot go further than 2 because that other ordered pair would not be on the circle. Notice this is a maximum on the graph on the left displaying x versus theta. The second ordered pair is cosine of 90 degrees, also known as cosine of pi over 2 radians, which on a circle of radius 2 is the ordered pair 0, 2. As you can see, the shadow has no length along x because it is directly above x equals 0. Notice this value is 0 on the graph on the left that is displaying x versus theta. The third ordered pair is cosine of 180 degrees, also known as cosine of pi radians, which on a circle of radius 2 is the ordered pair -2, 0. As you can see, the shadow is fully along the x-axis, but this time in the negative direction. Notice this is a minimum on the graph on the left that is displaying x versus theta. The fourth ordered pair is cosine of 270 degrees, also known as cosine of 3 pi over 2 radians, which on a circle of radius 2 is the ordered pair 0, -2. As you can see, the shadow again has no length along x because it's directly below x equals 0. Notice this value displaying on the left that is on the graph x versus theta. Now let me rotate this to an appropriate position to properly demonstrate the sine function and plot a graph, this time y versus theta. From earlier we have r sine of theta equals y, where theta is changing and r is still a constant too. This time we're now shining the flashlight towards the vertical axis such that the red line is always between the source of the flashlight and the vertical axis. This light casts a shadow that is created by the red line, but on the y-axis this time. The shadow is the yellow line that you see here. I'm again going to perform some rotations and I want you to just watch and think about it. Notice the y value of the ordered pair and how it's the same as 2 times the sine of theta. I want to again investigate some crucial points on this graph. The first ordered pair I want to investigate is the sine of 0 degrees, which on a circle of radius 2 is the ordered pair 2, 0. As you can see, the shadow has no length along the y-axis. Notice that this is 0 on the graph on the left that's displaying y versus theta. The second ordered pair is sine of 90 degrees, also known as sine of pi over 2 radians, which on a circle of radius 2 is the ordered pair 0, 2. As you can see, the shadow has a maximum length along y. Notice this value is the maximum on the graph to the left that is displaying y versus theta. The third ordered pair is sine of 180 degrees, also known as sine of pi radians, which on a circle of radius 2 is the ordered pair negative 2, 0. As you can see, the shadow is again 0 because the shadow has no length along the y direction. Notice this is 0 on the graph on the left that is displaying y versus theta. The fourth ordered pair is sine of 270 degrees, also known as sine of 3 pi over 2 radians, which on a circle of radius 2 is the ordered pair 0, negative 2. As you can see, the shadow is fully along y, but this time in the negative y direction. Notice that this value is at a minimum on the graph on the left that is displaying y versus theta. Now let's bring the cosine function back in and observe them together. I will again let these rotations play out so you can pause the video and really think about this. Notice that when we make a rotation that's greater than 360 degrees, we are again in the first, second, third, and fourth quadrant, depending on how far we go. This is what we call oscillatory or periodic behavior. This is why that 2 times the cosine of 360 degrees is the same as 2 times the cosine of 0 degrees. They're both equal to 2. It's the same with sine, but it returns a different value. 2 times the sine of 360 degrees is the same thing as 2 times the sine of 0 degrees. They're both equal to 0. I will keep performing rotations for the end of this video. Feel free to watch, think about this, pause the video, reflect, and just inspect points. Thank you again for watching. Please comment below if you have any questions.